What's up everyone? So welcome back to my channel, and I know I didn't post any new videos for at least 2 weeks or maybe even 3 weeks, but either way, thank you for everyone who actually subscribed to my channel, and I finally reached the 200 mark. So I think it's time for me to actually follow what I promised to do, which is put more videos more often and more frequently. And second thing that I need to do is back then when I did the video of the cubic formula, there was a subscriber who actually asked me if I would make a video for the quadratic formula, and I promised that I would do it when I have time. So here is the goal. I'm going to make that video once I reach 250 subscribers. So if you want to watch that video as early as you want, try to ask more people to subscribe to this channel so that I'll post it once I reach the 250 mark. Okay, so today we're going to look at this equation here, which says 7x plus 1 times 9x plus 1 equals 61. So it's just a basic algebra problem, and of course, as you can see, even a high school student can do it because it is just a degree 2 equation. So of course we can simply just multiply the left hand side and then use the quadratic formula to help us solving this equation. But again, for people who are new to algebra or are not familiar with it, it might actually take a little bit long time just to multiply and then try to either factor or use the quadratic formula to simplify the answers. So today we're going to look at a different method, a method that I think is quite brilliant, but we'll also talk about why we are allowed to use such a method, or what kind of conditions we need in order to allow us using that method. So I'm going to quickly go over the method that we're going to use, because this problem is not my original problem. I didn't think of it. I actually found out this problem from a video from a different channel, and I'll actually put the link in the description. So if you're interested of the original post, you can go to check out that video. But that video is actually spoken in Mandarin Chinese. So in order to know what they're talking about, you perhaps need to understand what they're saying in Chinese before you know why it will get into each step. So here we go. In that special method, what they did is, instead of multiplying the left hand side and then to get the general expression, what they did is they will actually multiply both sides of the equation by the product of the two leading coefficients. So in this case, there's a 7 in the first term, and then the leading coefficient is 9 in the second term. So what happened is we're going to multiply 7 and 9 on both sides of the equation. In other words, we're going to multiply both sides of the equation by the product, 63. Okay, and then after that, what he did is, or what we do in this method is, we're going to distribute the 63 again, which is 7 times 9, into the two factors on the left hand side, where the 9 is gonna multiply into the first factor and the 7 is going to multiply into the second factor to give us 9 times 7, which is 63x, and then plus 9 for the first factor, and we get 63 x plus 7 for the second factor, where the right hand side is now 61 times 63. What we're going to do is we're going to rewrite 61 times 63 into, of course, we need to switch the order a little bit. So we're going to rewrite as 63 times 61 first. Then we're going to break 63 and 61 into 62 plus 1 and 62 minus 1 respectively. And after that, we're going to do completing squares on both sides, meaning we can just see that this is a difference of squares. So we can just use the formula to give us 62 squared minus 1 squared. Now on the left hand side, what they did is we're going to find out the average of these two factors, which is 63x plus 9 plus 63x plus 7, all divided by 2. And again, we see that the difference is just 2. So, in other words, the average will be 1 less than this and 1 more than this. Then we're going to rewrite as 63x plus 8, which is the average, or you can call it the mean in statistics. Then we have plus 1, so that we can add up back to 9 here for the first factor. Times, similarly, we have the average here, 63x plus 8. Now this time we're gonna have minus 1, so that when we put together, we'll be able to get 7 back. And once again, we now can write it as this big term, the average, plus 1 times the average minus 1, which is, again, we can use the formula for difference of squares to get the following. The average square minus 1 square, which is equal to the right hand side, and we see that the 1 cancels out, so that we have the average square is equal to 62 square. Then we can solve it without using the quadratic formula, because if we have a squared is equal to b squared, we can just square root both sides to get a is equal to b, or a is equal to negative b, and later on we can just solve for x, which is part of the a term. Alright, so that is the idea of the method. But why are we allowed to use it? Or what are the conditions that we actually need in order to use this method, so that when we actually need to solve for it, we don't need to use a quadratic formula first of all, and we don't need to multiply these two factors together in order to get the quadratic expression and be able to solve it. And if you're actually very familiar of this method already, you probably can do it in your head and figure out the answer in 30 seconds. But again, when are we allowed to use it? So let's pause the video for a bit and let yourself think about the conditions. Then we're gonna go over it. Okay, so let's try to make the expression more general. So instead of having numbers, we're going to use some dummy variables to do the expression. So we're going to get the first factor, ax plus b, and again a and b are just some constants, times the second factor, cx plus d, which is equal to some constant on the right hand side, and let's call it k. So in order to use the method, we need to actually know the relationship between a, b, c, d, and k. And again, a, b, c, d could be any random numbers, but once we decide the four expressions, once we decide the four coefficients on the left hand side, we need to check what k is, and k cannot be any arbitrary constant anymore. We actually do need some conditions for k in order to use such a method. How do we know what k is? So let's do the algebra. So keep in mind, in that method, we first decide to multiply the products of the leading coefficients on the left-hand side, meaning we're going to multiply both sides by AC. And here I decide to color code each coefficient so that it's easier to recognize. So on the left-hand side, we get the left-hand side, which is AX plus B times CX plus D. But now we need to multiply by the products of AC. So we get A times C times AX plus B times CX plus D. And of course, when we take something on the left-hand side, we need to do the same thing on the right-hand side. Otherwise, it will change the value of the two sides. So what we're going to do is, on the right-hand side, we also need to multiply by AC. Again, we have A times C times the constant K here. And this is the first step of the method that we actually used. Then we're going to distribute the AC on the left-hand side into each factor. And again, since we want our leading term being the same in each factor on the left-hand side, we now need to distribute the A into the factor that starts with CX. Similarly, for the C term, we need to multiply into the term that has AX, such that now we get AC times X for both terms. And again, I'm not going to color code anymore. We have AC times X and then AC times X as our leading terms. Now, since we are multiplying, of course, the B term will now become B times C, which is BC. Let me use this here. And then for the D, we actually get the A multiply in, so we now get AD. Good. Now the right-hand side is still the same because it's just a product and there's nothing much we can actually do right now. But we will actually see how this is going to affect our result. And maybe I should just color code K again because this is what we want to find out at the end. We need to know the condition of K. All right, so in this case, we are actually almost done because now we just need to take the next step. That is, we need to find the average of these two factors. And again, to find the average of the two terms, we just need to add them up and divide by 2. So the average will become ACX plus BC plus AD all divided by 2. Or if we simplify it, we'll get ACX plus the quantity BC plus AD all over 2. And this is what the average value would be. Average. So on the left-hand side, we now have the first term will become the average plus BC minus AD over 2. And again, if you don't believe it, you can just add them back up and see if you actually get BC here. For the second term, we will now get the average plus, or you can actually use minus this thing, but we can also distribute the negative to get AD minus BC over 2. And again, you can add them up to check your work. And that should give you the second factor. Now, on the right-hand side, remember, you also want to distribute it into two factors and to match the left-hand side. And the way that we did it is we will just leave it as AC times K. And we now need to find the average of these two values. So again, AC times K, so we have AC and K. The average of it is, again, by the average formula, we have the sum AC plus K all over 2. Good. And as this is the average, in order to turn this into average, we need to add something and subtract something. So this is what we're going to add. In order to get AC, we need to have half of AC more, but then we have an extra K over 2, so we need to subtract that. Times K, which is, if we try to use the same notation, we will actually get this minus that, or we can rewrite as K minus AC over 2. Good. And now we have the expression of something plus something times something minus something. And again, it is just the same as the square of difference of squares. So if we try to multiply in by the formula, we will actually get the following expression. We have the average square minus the half of the difference squared. And again, the right hand side would just be the same. We have the average square minus the half of the difference squared. Good. So what can we tell? First, can we use the first term on both sides to do a comparison? Yes. And in fact, this is what we want to do in order to solve for x. But we cannot just use it to help us determine what k is. And that's again because we have the variable x that we need to solve for. So this part and this part doesn't really help us to figure out what k is. Then what is remaining? Well, we still have this part here, the square that's actually being subtracted. And if we compare comparing these two terms, there's no more independent variable x, or the variable that we need to solve for in the equation. So now it is only depending on a, b, c, d, and k. Therefore, we can actually do a comparison between these two. So let's move to the next board and finish up our calculation. So in the last board, we end up with the expression, and we claim that in order to find out the condition of k, we need to have these two terms being the same. So of course, we also should include the negative sign, but again, since we have negative of the square is equal to negative of square, we just cancel the negative. So we just need to look at these two terms, and we'll be able to figure out the condition of k that we need for such method. So if we look carefully, we have the square of this fraction is equal to the square of that fraction. How do we solve it? Of course, we take the square root, right? So if we take the square root on both sides, the square root and the square roots will of course cancel out. And then here, the square root and the square will cancel out. So what do we get? Now we only have BC minus AD all over 2, which is this part here, is equal to AC minus K over 2. And again, I should color code K because this is what we're looking for. But is that it? No. Remember, when we solve for equations and take the square root, and again, even we're only solving for real numbers, when we need to take away the square and put the square root, we need to put plus and minus sign on at least one side of the equation. And again, some people may ask why we don't need to put it on both sides, because even if we put it on the other side, we'll be able to cancel out. So it's enough to just put it on one side. So let's say we're going to put it on the left-hand side in this case, because the left-hand side is just a constant. There's no K here. Then we can now continue working on our equation and solve for K. So what can we do first? Well, we have a 2 in the denominator, a 2 on the denominator. Let's cancel it. So that we now end up with BC minus AD. And then don't forget, we have a plus and minus sign to tell us that there are 2 different cases, which is equal to the right-hand side, AC minus K. So we're almost done. To solve for K, we can just put the K on the left-hand side by adding K on both sides, so that we have K is equal to, on the right-hand side, we still have AC, and then for the constant term on the left-hand side, we need to put it on the other side. So we now need to flip the sign from positive to negative and negative to positive. So we will end up with minus plus to the other side. And then what are we going to do? We're going to minus or plus whatever the constant is, BC minus AD. But again, minus plus are just telling us that there are 2 cases, and the 2 cases are either adding or subtracting. So this is just the same as writing it with plus or minus. Good. So that is it. So we found the condition that we need in order to use such a method. If we have any arbitrary A, B, C, and D, then the constant term on the right-hand side of the equation, K, must satisfy such condition, AC plus BC minus AD, or AC minus the quantity, BC minus AD, so that we're able to use the method and try to find out the solution of the quadratic expression without multiplying in the left-hand side, or use the quadratic formula to help us get the answer. So I think it's pretty cool. If you enjoyed this video, please don't forget to like. And if you didn't subscribe to my channel yet, please go subscribe so that you will be able to find out more of my other videos. And if you did not turn on the notification, please do so that you won't miss any of my new videos either. And one more thing before I end this video is, after I reach 200 subscribers, I finally have unlocked the function of community, so that now I'll be able to post anything if there's any special situation, or if there's any coming up videos that I would want to let you guys know. So that's it. Thank you for watching. I'll see you guys next time.